Good morning. Today we discuss about Kohenen self-organizing maps. So, in neural networks which use a pre-processing inspired by the human brain as a basis to develop algorithms that can be used to model and understand the complex patterns and prediction problems. There are several types of neural networks and each has its own unique use. So, we have one variant which is called self-organizing map of the neural network, which is also known as a coherence map. So SOM is called as a coherence map, or it is called as a coherent self-organizing map. So this self-organizing map, it was produced by the Kohenen, and it is an unsupervised neural network that is trained using unsupervised learning techniques to produce a low-dimensional, discretized representation from the input space of the training samples, known as a map, and it is used to reduce the data dimensions. Self organizing maps are very difficult and it's different from other artificial neural networks as they apply competitive learning techniques unlike others using error correction learning methods such as backpropagation with gradient descent, and also it uses a neighborhood function to preserve all the topological parameters properties within the input space. So this map were initially only being used for data visualization, but these days, it has been applied to different problems, including as a solution to the traveling salesman problem as well. So, this map units or neurons usually form a two-dimensional space, and hence a mapping from high dimensional space onto a plane is created. So, you can see this is going to be a layer of a coherent map. So, we have an input layer like x1, x2, xn. These are the input parameters with the input layer, and we can able to see the output layer which is future mapped. So here it does not only having the neural networks but also it has a future map. So the output you can see all these layers like w1, 11, 12, 13. So you have n number of output layers. So as we said before, each neuron is a SOM is assigned a weight vector with the same dimensionality as the input space. So in this example, each neuron of the output layer we will have a vector with a dimension n. We will compute a distance between each neuron and the input data and the neuron, with the lowest distance will be the winner of the competition. So the Euclidean metric is normally we use to measure the distance between the two vectors. And we will update the vector of the winning neuron in the final process, that is adaptation. But it is not only the one, it on also its neighbor will be updated. So then how do we choose a neighbors? To choose a neighbors, we use neighborhood kernel function, and this function depends on two factor, that is a time incremented each new input data and distance between the winner neuron and the other neuron. That is how far is a neuron from the winner neuron. And you can see these algorithms like initialize, we have to initialize the weights to some small and the random values, repeat until the convergence. And you have to select the next input pattern, that is x of n from the database. And next, from after selecting the input pattern, you have to find what is wi, that is weight, and that is best matches the input pattern x of n. So I of x power n is equal to arch min of x power n minus wj. And after that, update the weights of the winner wi and all its neighbors wk. And decrease the learning rate eta of t and decrease the neighborhood size tau of t. So what are the pros and cons of this SOM? Pros. Data can be easily interpreted and understood with the help of techniques like reduction of dimensionality and grid clustering. These maps are capable of handling several types of classification problems while providing a useful and intelligent summary from the data at the same time. What are the cons? It does not create a generative model for the data, and therefore the model does not understand how data is being created. And these maps do not perform well while working with categorical data and even worse for mixed types of data. This model preparation time is comparatively very slow and hard to train against the slowly evolving data.